so today I'll be explaining the Math AMS quiz of Term 1, Week 2. So, which of the following relations is not a function? Is not a function. Now, whenever we have them in forms like these, in forms of an equation, a quick trick to know if it's not a function, it has to have either absolute value or it has to have an even exponent, even as in 2, 4, 6, etc. Okay? So we already know that these are the two conditions. Let me explain a bit further why. Let's say we have 2. X is let's say we have y as minus 2 over here. We have y as minus 2 and y as 2 in the absolute value form. If that's the case, we're gonna get x. So the absolute value of 2, if we try it, it is 2. So that means our x is 2 and our y is 2. And the absolute value of negative 2 is 2. So our x is 2 and our y is minus 2. And whenever we have the same x but different y's, then it is a relation that isn't a function. So it's a relation and not a function. Now, if we're talking about even exponents, let's take for example 16. Our y is 16. So y to the power of 4 is equal to 16. Y could be either positive or negative 2. Okay? So we have 16 as our x. Okay? And we have as our y either positive 2 or negative 2. So again, look, we have the same x and different y's. So that means it is a relation and not a function. So if we apply what we just explained in this example, they need those that are not a function. We take the ones that have absolute value and the exponents that are even. Now, question number 2. Which of the following relations is a function? So we said those that are not a function, they are the ones that are in absolute value and the ones that have even exponent. So if we need to take the ones that are a function, we don't choose these. That means this is a function and this is a function. This is not a function. This is a function and this is not a function. Question number 3. The figure below displays 3 circles. 2 of these circles each has the radius 2, while the radius of the third is 4. Which of the following statements is true? So they're talking about congruent arcs. An arc is congruent to another only in these 2 cases. They both have to be applied. First, they have the same radii and the same measurement. So, what is the radii? I will color the radii in blue. This is a radii, this is a radii, this is a radius. This is radius, this is radius, this is radius. So all the ones in blue are radii. And what is a measurement? It's the ones I will color in red. This is a measurement. So are these and these. So the blue is the radii and the red is the measurement. If you notice, the measurements are all the same, but the radii are not. So that means we have to pay attention when we are choosing the congruent. So minor arc LM is congruent to arc LK. LM and LK, they have the same radii and the same measurement, so yes, they are congruent. LM is congruent to RP. LM here. Is it congruent to RP? This is 2, this is 4. No, they are not congruent. They have different radii. AB is congruent to LM. Is AB congruent to LM? No, this is 4, this is 2 different radii. QR, is it congruent to KL? This is QR, this is KL. No, they are not congruent because they have different radii. BC is congruent to LK. This is BC. And this is LK. No, they are not congruent because they don't have the same radii. And finally, AB is congruent to PR. This is AB and this is PR. Yes, they both have 2 as a radii and 50 as their measurement. So the only two are LM is congruent to LK and AB is congruent to PR. Number 4, which of the following is true about the measure of a minor arc? Let us see. In degrees, the measure of a minor arc is equal to 90 degrees? No. A minor arc, it ranges between 0, it's definitely greater than 0, okay? But it is less than 180 degrees. And not all minor arcs are equal to 90. So here they're saying, in general, the measure of a minor arc is equal to 90. No, it is between 0 and 180 degrees. So, second one, if the central angle is straight, its corresponding arc is a major arc. Let's draw a circle. Okay, and we have straight here. This is the central angle. That means 180 degrees here, 180 degrees here. If this is minor and 180 and this is major and 180, does it make sense? If they're the same value and one is a minor and one is a major, no. So that means the second one is incorrect. In degrees, the measure of a minor arc is between 180 and 360. No, we said between 0 degrees and 180 degrees. If a central angle is acute, its corresponding arc is a minor arc. So let us try. This is a circle, and they're telling us if the central angle is acute, so let's say like this, then the corresponding arc is a minor arc. This is the corresponding arc. Is it a minor arc? Yes. So this is correct. Now they're telling us if the central angle is obtuse. First of all, acute, it means between 0 and 90. And obtuse, it means between 90 and 180. So if they're telling us the central angle is obtuse, let's take for example like this. This is obtuse. Okay, it's greater than 90 but less than 180. The corresponding arc is a minor arc. Is it a minor arc? Is this a minor arc? Yes, it is, because this over here is still bigger than it. It still has a bigger value than it. And it is, then here is the major and here is the minor. So yes, this is also correct. And in degrees, the measure of a minor arc is less than 180 degrees. This is very true. It is between 0 and 180 degrees. So the 3 last for me are the correct ones. The diagram below shows a circle with the center O. Which of the following is a central angle of this circle? A trick for central angles, it has to have the center as the middle letter. So this means we're going to have an angle, for example, POM. Sorry, it's like this, POM. Okay? We're going to name it angle what? POM. Since O is the center, okay, it's a central angle. So any angle that it starts with a point that's on the circle, ends with a point that's on the circle, and has the center as the middle letter, it is a central angle. So LOM is POL is and MON are central angles. Now, which of the following points belong to minor arc KN? Watch out in the exam if they tell you minor or major. So this is arc KN. Are they talking about the one in blue or the one in pink? Definitely the one in blue is the minor. So the points that are on minor KN, it is K, R, L, and N. So our answers are K, R, L, and N. Number 7. Which of the following belong to major GD? Where is GD? Here is G, C, D. G, C, D. Okay. Which one is the major? The one in red or the one in green? Definitely the one in green. So the points that are on major GD, they are D, F, B, and G. So D, B, F, and G. Number 8. The figure below shows 3 circles. 2 of the circles each has a radius 8, while the radius of the third is 16. Which of the following is congruent to minor PQ? Which one is minor PQ? This is minor PQ. So that means they have to have a measurement of 65 degrees and a radius of 8. Which of the following have a measurement of 65 degrees and a radius of 8? We have RQ, we have YZ, and we have XY. So the 3 possible answers are RQ, YZ, XY. QR or RQ, YZ, and XY. Number 9. 2 of the circles each has a radius 4, while the radius of the third is 8. Which of the following is congruent to DE? It's the same as before. DE has a radius of 4 and a measurement of 70. So which one has a radius of 4 and a measurement of 70? We have AB, we have BC, we have FE. So AB, BC, and FE. BC, AB, and FE or EF. Number 10. Consider a relation T defined by the rule y equals -1 plus or minus 2 radical x, where x is drawn from the domain 0, 1, and 4. Some things to explain. A domain is always given, and domain is always the x. The range we need to find by substituting. So R equals substitute. Okay, it's the y. I'm gonna write it up. D equals x, domain equals x, range equals y. Let us substitute. We have x as 0. Okay, we're gonna take them as points. First off, we have x as 0. If we substitute it here, we're gonna have -1 plus or minus 2 radical 0. Radical 0 is 0, and anything times 0 is 0. So that means we have -1 plus or minus 0. Whatever you get, it's gonna be the same answer, -1. So 0 minus 1. Next, let's take 1. 1 as the domain, and let's find the range. We have -1 plus or minus 2 radical 1. We can have either -1 plus 2 or -1 minus 2. If we have -1 plus 2, what will we have? We will have 1. And -1 minus 2 is -3. So our points are either 1, 1, or 1 minus 3. Let us now do 4. Substituting by 4. We're gonna have minus 1 plus or minus 2 radical 4. So we will either have minus 1 plus or minus, minus 1 plus 4 or minus 1 minus 4. If we do minus 1 plus 4, we will get 3. So that means we have 4, 3. And if we do minus 1 minus 4, we will have minus 5. So 4 and minus 5. That means we have 5 points. That means the range contains 5 values. Okay? Relation T, is it a function? If you remember from what we previously did, from what we previously solved, if we go back to what we solved before, we're gonna see that we have some solutions, they have the same x but a different y. And we said if they have the same x and a different y, it is not a function. So, because they have the same x but a different y, it is not a function. So, if you remember the points, we had 0, negative 1. Then we had 1 and 1. No, sorry, we had 1 and 1, and we had 1 and negative 3. And then we had 4 and 3 and 4 and negative 5. So it was something like this. The scatter plot was something like this, based on the points that we got from before. Now, true or false? 1, 3, 2, 2, 3, 1 is an example of a relation that pairs elements from the set A to the elements from the set B. Let us see. 1. Is there a 1 in set A? Yes. 3. Is there a 3 in set B? Yes. Okay. 2. Is there a 2 in set A? Yes. 2. Is there a 2 in set B? Yes. Now here. 3. Is there a 3 in set A? No. If you have one no, then directly the answer is false. F. Number 12. Consider the relation R, this, which is the smallest element in the domain of R. If you remember, domain is the X and the range, the R, is the Y. Here they're asking us for what? The domain, so we have to take the smallest X. Which one is the smallest? We have 12, 14, 17, 18, 19, 20, 21. It is definitely 12, which is the smallest element of the domain. Now, they're asking for what here? They're asking for the smallest element in the range of R. So the smallest what? The smallest Y. And which one is the smallest Y? 12, 13, 14, 17, 90, 11, or 10? It's definitely 10. Now question number 14. This is a very, very important question, okay? We have 1, 2, 12, 23, 12A, 13, 16, 13B, 14, 20, and 14C. Okay? We have A, B, and C are constants to be determined. So, what must be the value of B for R to be a function? What does a function mean? It means we have one X, it has a specific Y, and it doesn't have any other Y. So for this to be the case, they want us to find the value of B. We already have a 13, yes? And what's the Y? It's 16. So for it to be a function, the X has to be the same, which it is, okay? And the Y has to be the same, so they can be the same point. So if they are the same point, then it will not be considered that we have the same X but different Y. No, we have the same X and the same Y, so it will not affect the function. It will stay a function. So that means the value of B has to be 16. So 16. Number 15. Which point, if removed, makes the relation a function? Definitely, if it's a function, it should not have the same x and a different y. So look, this is the same x and a different y. So if you remove, for example, the u, okay, it will be a function. If you remove the p, it will be a function. So they said if more than one point exists, enter any of them. Let's, for example, enter p. So p, if you remove it, then it's gonna be a function. Why? Because we have different x's, okay, and different y's. Even if they're different x's and they have the same y, it works. But if they are the same x and they have different y's, it will not work. It's not a function. Number 16. The function p is given by pt, 5 minus 3t, blah, blah, blah. What's the value of p negative 2? The only thing we need to do is substitute. So p minus 2 is equal to 5 minus 3t. Since we replaced the t over here by minus 2, that means we're going to replace the t over here by minus 2. So 5 minus 3 times minus 2, 5 plus 6, so our answer is 11. Number 17. This is a very good question. 11 plus 2t squared, okay, pt equals 11 plus 2t squared. Then if we're going to replace it by this, then what is our answer? If you notice, our t is squared. So that means directly, without having to substitute it and then go through a big process, we can do 11 plus 2 times 3t plus 1 squared. We can do 3t plus 1 squared mentally. It's gonna be 9t squared plus 6, sorry for my plus, it looks like a t, plus 6t plus 1. Okay, now we're gonna multiply it all by 2. What will we get? We will have 11 plus 18t squared plus 12t plus 2. And 11 plus 2 is what? 13. So our final answer is 18t squared plus 12t plus 13. So our box is 13. Number 18. As we said, that the domain is x and the range is y. So they're asking what is the largest number in the range of p. They need the biggest possible y. If you look here, it's all positive. So since it's all positive, if you substitute by the biggest number in the domain, you will get the biggest number in the range. So since 20 is the biggest number, let's substitute by it. We're going to have 10 plus 2 times 20. So 10 plus 40, so 50. That's our answer, 50. Number 19. The function h is given by hx is equal to radical 48 minus 4x. The domain of h is, okay, whenever they're asking for a domain and they give you something like this, now the domain doesn't mean necessarily the x, it means what the x is, okay? So, like, we need to solve for the x here whenever they ask us for the domain in this type of question. Here, if we have a negative value in the radical, for example, negative x, will we get any answer? No. So we have to make sure our value is not negative. How do we do that? Whenever we have a radical, we have to take the x outside, and we have to make sure that the x is greater than or equal to 0. It should not be less. It can be greater, it can be equal, but it cannot be less, because we cannot have a negative under the radical. So if we apply what we just explained, we're gonna get this. Radical 48 minus 4x. We take this outside. It's gonna be 48 minus 4x. We said because it is a radical, it's supposed to be greater than or equal to 0. Bring the 4x here. What do we have? Now we're going to have 48 is greater than or equal to 4x. So now 12 is greater than or equal to x. Here, they started with x, so all you have to do is flip the sign. That means x has to be less than or equal to 12. So x is less than or equal to 12. Number 20. The function h is given by hx equals x plus 11 over 2x minus 66. Now, remember, try on your calculator, for example, 1 over 0. It will give you what? Error. That means what? Our denominator cannot be a 0. Since this is the case, we take the 2x minus 66 and we make it different than 0. So we bring 66 to the other side. We're going to have 2x is different than 66. X is different than 33. So here what are they asking? They're asking what number is not in the domain of h. That means it is 33. Number 21. The function u is given by ux is equal to x plus 1 over x squared minus 5x plus 4. Give a number that is not in the domain of u. If more than such number exists, enter any of them. Okay. If you remember, whenever we have a denominator, what do? We make the denominator different than 0. So x squared minus 5x plus 4 different than 0. If we factor it by doing the product sum, you're going to get x minus 4, x minus 1 different than 0. So x is different than 4 or x is different than 1. You can put any of them, both of them work. So if you put 1, it's correct, and if you put 4, it is correct. Number 22. In the figure below, O is the center of the circle and P, Q, R, and S are points on its circumference. Check the proper box to determine whether each arc is a minor or major arc. Okay, first arc is PSR. PSR. Does it look like a minor or a major arc? It looks like a major arc because it is greater than 180. PQR. PQR. Does it look like a minor or a major arc? Does it look like a minor or major arc? It looks like a minor arc. So we put minor arc. P, Q, S. This is definitely a major arc. It's so big. So we're gonna call a major arc. Number 23. Now, number 23. The diagram below shows a circle with center at C. Okay, so in the question, what do they tell us? They tell us that with segment with diameter Kn, they're telling us find the number of points in the semicircle that contains Q. So what what is the semicircle that contains Q? It's this one. And now we have K, we have R, we have Q, and we have N. We do not take the points that are inside, we never consider them, and we don't take the points that are on the diameter. It's never considered. Okay? So the points not considered are on the diameter and in the semicircle. The only ones that are the ones that are on the arc. So we have 4, K, R, Q, and N. So that is why we have 4 points on the semicircle Kn that has Q. So we have only 4 points that belong to this semicircle. The diagram below shows a circle with center O. If the degree measure of a minor arc LM is 70 degrees, then the degree measure of minor arc MN is... Just by looking at it, okay, this is 180 degrees. So if this is 70 degrees, how much will this be? It will be 110 degrees. So our answer is 110. In other words, you can do it in two ways. You can either do it that this is a semicircle and a semicircle is 180 degrees. If this is 17, then this is 110. Or you take the triangle. We know that the arc is the same as the angle. So this is 70 degrees. And since it's a straight line, this is definitely going to be 110 degrees because 110 plus 70 is 180. Now, the diagram below shows a circle with center C. The degree of the major arc AB. Look, the major arc AB. They need the degrees. What do? We know that in a circle, the angle is 360 degrees. Okay? And they're telling us they need only this. They don't need this. So we're gonna take this over here and we're gonna remove it from the 360 degrees. So minus 115 degrees. We're gonna have here 5, here 4, and here 2. So 245 degrees. Question 26. The diagram below shows a circle with its center divided into 12 congruent angles, each of measure 30 degrees. Okay, if each of measure 30 degrees, then that means the total circle is 360. Okay, because 12 times 30 equals 360. And this is correct because in a circle, the angles are 360. Now they're telling us, what is the measure of arc GFM plus the measure of arc MDB? We have what? GFM and MDB. Where is GFM? This is GFM. And where is MDB? This is MDB. So we take all of this and we count. This is 1, 2, 3, 4, and 5. So 5 times 30 degrees, it gives us 150 degrees. So 150 degrees. Number 27. The measure of minor arc UV is x minus 10. The measure of minor arc VW is 2x minus 220. What's the value of x if the measure of minor arc UW is x degrees? We have UW is how much? X degrees. So what's the value of x? X is equal to x minus 100 plus 2x minus 220. So x minus 3x is equal to negative 320 minus 2x is equal to minus 320. So then x is equal to 160 degrees. Number 28. Okay, the diagram below shows a circle with center C. The measure of minor arc YZ is x minus 15. And the measure of arc XZ is 150. So, if XY is congruent to YZ, that means we can split 150 in half to get 75, okay? Now this 75 is equal to what? This, x minus 15. So we bring the minus 15 to the other side. It's going to be x is equal to 75 plus 15, which is 90 degrees. So our answer here is 90. And finally, 29. The diagram below shows a circle with its center divided into 12 congruent angles, each of measure 30 degrees. Okay, what is the measure of minor arc KC? Where is KC? This is K and, oops, sorry. This is K and that is C. So if they're asking for the minor, are they asking for the blue part or the green part? They're asking for the green. It is the minor. Now they're asking for the measurement. So what do we have to do? We just add. We count how many there are. We have 1, 2, 3, 4. So 4 times 30 is 120 degrees. So our answer is 120 degrees. Number 30. The diagram below shows a circle with its center divided into 12 congruent angles, each of measure 30. Now they need what? They need the major EB. Let's take EB. Where is EB? EB. They need the major, so we take the bigger one. How much is there? We have 12 minus 1, 2, 3. So we have 9 over here. So we do 9 times 30 to get 270 degrees. So if we're gonna put our answer, it's gonna be 270 degrees. Now let's check. Alright guys, thank you for watching this video and I hope you enjoyed it.